This is Greg Pasternak from Riverside Life, and I'm continuing the series on the different stream types in California. Today I'm in the south central coast region of California, and I happen to be in the town of San Luis Obispo. And running right through the town is the creek of San Luis Obispo Creek. So let's talk about the attributes of this creek. I always like to start by talking about the valley context, and when you look at the valley here, you'd think that this is a confined valley because we seem to be down within, like the channel's down within, right? But of course, it's not that. And this is what makes this a little bit more confusing, especially when you get to an urban or agricultural river. What's happening in this case is the valley, which is like the valley floor, is try to put my hand, is like sort of up at that level. And I'll spin around to just show a bridge. So you can see a little bit. It's going to take me a minute to get this around. Sorry about that. And let's talk about the valley confinement in this case. So if you look here in the video, there's a bridge above the stream, okay? And the bridge is at the valley floor level. So relative to that valley floor, the confinement provided by the valley walls is quite far away. It's like 1.5 kilometers away. So from that perspective, this would classify as an unconfined valley or a stream in an unconfined valley. However, as you can see, the distance between the bridge and the channel is quite high. When we have a stream where the valley itself is unconfined, but the channel is far down compared to the valley floor, we call that entrenched. Entrenched means that, for the bankfull dimensions of the channel in terms of width and depth, it's much farther down from where you see the geometric break of the valley floor down to get to the geometric break of the channel. So the channel is inside this inset, almost like a canyon unto itself, and that's called an entrenched stream. Now let's talk about the classification of this particular stream within both the California statewide classification as well as the South Central Coast region regional classification. So I'm going to step out here a little bit so you can see the stream. And the first thing that should be quite striking is that where we're standing right now, it's predominantly bedrock. Now this isn't the site where measurements were taken. I'm going to make a separate video a short distance away, but I thought this is a good place to start. So this has got a lot of exposed bedrock, which puts us immediately into a bedrock class of river. But in other aspects of it, there are boulders here. The grain size tends to be predominantly cobble with some gravel. And in the distance down there, there's actually a step. The step means that you have the tread, which is the flat, plain bed, and then a riser like you have on a staircase in your house. So the riser drops down, and then it's sort of flat again. So we might think of this as almost like a plain bedded section, but right where we're standing, there's a little bit of a riffle. So we're seeing a mix of features. We're seeing a plain bed, kind of flat uniform section. We're seeing riffle, we're seeing steps, we see little pools. So that's a lot of diversity to try to all integrate into one classification, and all of those features can't win. So this one happens to be classified as a confined cobble boulder riffle pool stream for the regional classification. It's a regional class 8, statewide class 1. Those numbers don't particularly matter. I think the words are more important. So in both of the classifications, it's being classified as confined, even though it's in an unconfined valley. And I think the reason that explains that is that because it's so entrenched, it's taking on many of the attributes of a confined river. So I'm going to move now to the site where the measurements were taken, and we'll talk more about it there. I'm still on San Luis Obispo Creek, and all I've done is I moved upstream, like 20 meters, 60 feet or something like that. It's really not that far. You can see the bridge. It's the same bridge that I talked about earlier. I'm just now upstream of the bridge instead of downstream of it. And yet the character of the river has changed, and it's really now much more like what fits the classification, so I can see what's going on. And so at this site, what you can see is there's an alluvial bar right here, primarily composed of gravel with some cobble in it. And when we look at the topography of the river, it's now a riffle pool, no question about it. There's a lot of small, boulders and large cobbles that are in the channel. At the downstream end is a little riffle. Right upstream, right at my feet, there's a little riffle. There's some little pools. There's not a whole lot of bed undulation here. It's relatively subtle, but there actually is a moderate amount of width undulation. And it's interesting because in terms of the numbers of this site, the width variation here is relatively small. But consider that the site I was just at downstream of the bridge was, scoured to bedrock and was very, very constricted. And then look here, we've got a gravel bar, and it's actually quite wide. When you look at the width of the channel, you look at the toe of the vegetation that's off on the hillside here, these big trees, its roots are exposed. So we have a really gradual bank on river right. We have a relatively steep artificial bank on river left. That's different. But because this particular section where the measurements were taken is a relatively wide unit, it's allowed for this alluvial veneer to deposit with quite a bit more sediment and give it this riffle pool character. Now, that also is indicative of the fact that at a very short, spatial scale, you can have dramatic changes in channel type. And I'm just gonna turn the camera around so that you can see what it looks like upstream. I think I can do it more smoothly. So hold on a second, because I want to show you how dramatically it changes again when you go just now upstream. And so you look upstream from where we are, and boom, we're right back into a bedrock-based river. I mean, there's very little alluvial sediment visible. It's scoured to bedrock, throughout the channel. So actually, the character of this, we've seen an upstream bedrock, we've seen a width expansion that had deposition of sediment, and then a downstream back to bedrock. So in many ways, the bedrock is more indicative, and you look into the distance upstream, you see, we're at about a 1 to 1.5% slope. And we're of course, at a very low base flow right now. It's not that exciting, but it helps you to see the topography quite well. So this is really a bedrock dominated channel, and actually in the river classification, we don't specifically call out that for this site. So that's something to think about as we continue to adjust the classification. But anyway, so this site classified, let me go back to the main site so you can see that again. So here we are. And so so this site classified as a confined cobble boulder, steep channel with riffles and pools, basically. And you can see that it largely is matching that, but there are a few things going on here. It's not a confined valley, but we are entrenched. And this particular site happened to be a little bit wider, which created that deposition. And otherwise, we're in a bedrock channel. That's just what we have. Okay, so that's this San Luis Obispo Creek site.